In this example, a multi-shot icing simulation has already been performed, and Fluent meshing was used to remesh the domain to take into account the ice displacement between shots. Begin by heading to the project view, find the multi-shot run folder, and expand your selection. Notice that there are a large number of files within this folder. Each file has a tag composed of 2-digit numbers which defines which icing shot this is associated with. All of the files containing the tag 01 are associated with the first shot of ice accretion. All of the files containing the tag 06 are associated with the sixth and final shot of ice accretion, and similarly with the files in between. The final part of the file tag defines the different solution types for each part of the solution process. The .droplet files are the solution files for the particles portion of the run. The ice.grid, map.grid, and .swimsole files are for the icing portion of the run. Finally, the 3.converge files are associated with the plotting of the convergence of these three solvers: F for fluent airflow, P for particles, and I for icing. You can interact with these files directly inside the run. If you want to look at the convergence of the first shot of airflow, you can right-click on the convergence file and select View Convergence. The convergence plot will now be displayed in the graphics window. If you would like to look at the solution for the second shot of the particle run, you can click on the second droplet solution file. You can load this or view it with external post-processing tools. Select View with ViewMiracle. You may be asked if you would like to open the numbered dataset. Select No, as you will only view the second droplet solution for now. You now have the grid and solution for your second shot of icing, and the solution specific to the second shot droplet particles run is displayed. You can use ViewMiracle to hide one of the boundaries, and you can zoom in on the surfaces of the swept wing to view the solution of the second shot of particles. You can change the data type to be viewed under Data to be Collection Efficiency. This shows the water catch efficiency on the surface of the Onera M6 wing. If you want to display a 2D cut of the collection efficiency of the surface, you would go to 2D plots and enable 2D plots. Set target to all walls and domain. Set the cutting plane to 0.6 to cut in the Z direction. Set a cutting location of 0.2 meters to look at the cut at the Z plane at 0.2 meters. Here you're showing the variation of collection efficiency on a Z cut of 0.2 meters over the y-axis. You can click on this curve to display the maximum value of collection efficiency at this cut, which is about 0.58. You can close ViewMiracle and remove the post-processing window and have a look at the rest of your files. To look at the ice-shaped solution for the final shot of icing, you can use CFD-Post as the post-processor, which contains macros for easier visualization of your ice shape. To access this capability, go to the View panel and under Quick View select Ice Cover. From the drop-down list, select Multi-Shot Ice Cover CFD-Post. CFD-Post will now open. A domain selector will appear. Select all available domains. In the CFD-Post window, we can now tell the solution and grids associated with our run have been loaded. To view these results, you're going to use a macro calculator. In the Calculators tab, select Macro Calculator and select Ice Cover 3D View. In Ice Cover 3D View, there are a number of options to help control the display for the ice shape. In this case, you will view the final shot of icing, which is the sixth shot. You're going to set the ice shape to a transparency value of 0.2 so you can also see the initial surface. Click Calculate to create the post-processing object. You can now see that the white ice shape is displayed over the gray surface of the initial swept wing. Now zoom in. Because you have transparency, you can see the location of the initial surface underneath the sixth shot of the ice shape. You can change the shot number to see an intermediate ice solution. For example, you can look at the second shot of ice accretion and press Calculate. You'll notice you are only seeing a smaller portion of the ice because only 2 shots are shown. In addition to the 3D View macro calculator for ice cover, you also have access to the Ice Cover 2D Plot macro calculator. Go to Macro and select this. You can display the ice shape by setting the multi-shot number to 1. Set the 2D plot width to multi-shot and change the plot title to Multi-Shot Remeshing All Shots. You can define the cutting plane location and the cutting plane point. In this case, you can select 0.2 to show the cut at 0.2 meters. You can change the y-axis range to have a better perspective by selecting User Specified. Change the maximum and minimum to 0.15 and negative 0.15. Press Calculate. A 2D plot has been calculated and a window opens displaying the final shot of ice in red, labeled Ice Surface number 6, and the airfoil in black, labeled Map Surface. The remaining curves show the intermediate ice shape shots. As you can see, it can be helpful to use available external post-processing tools to view the ice shape and results. This concludes our demonstration on how to post-process a Fluent Icing multi-shot icing simulation using Viewmerical and CFD-Post.